Quicksort is another recursive sorting process. The way that Quicksort works is the algorithm arbitrarily picks a pivot point and the elements are sorted around the pivot such that after a pass through the array, everything on the left of the pivot is smaller than it and everything on the right of the pivot is greater than it. This is similar to how you might quickly separate papers to pass back in a classroom for the left side of the room and the right side of the room. They're not necessarily in order, but they're partially separated with purpose. In the algorithm that we follow, we always attribute the pivot to be the last element, and then we make the first element what we call the I value. And the I value is what represents the current value that will be swapped with at the end. So as we move through the array, we are keeping track of where is the dividing line between the values smaller than the pivot and greater than the pivot. And every time we encounter a value that's smaller than the pivot, we swap it with this dividing line position, so to speak, so that way all of those smaller values keep on getting swapped to the front of the array, and then that dividing line slowly moves over to the right. And then when we reach the end of the array, the pivot point swaps with whichever value is at that dividing line position, and the end result is that everything left of the pivot is smaller than it, and everything right of the pivot is greater than it. So in practice, the way that we go ahead and do this is we are going to make our pivot the last element, and I will typically circle our pivot. We label the current I value as I, and it starts out as being the first element. And then as we progress through the array, we are going to compare each element to the pivot. If the element is less than the pivot, so not equal to, it has to be less than, then we are going to swap this element with the element at position I, and then we are going to increment I. If the value is not less than the pivot, then we just move on to the next one and we do not change I at all. When we get to the very end of the array and we are at the point where we are comparing the pivot to itself, at this point we would swap the pivot with I. And at this point we have finished one lap through the array, so to speak, and the pivot, we can say it's done and it's not going to move again. And then we're going to recursively repeat this process with all the values on the left of the pivot and all the values on the right of the pivot. To go ahead and demonstrate this, we're going to use the array that I have below. So we will start out with circling the last element as our pivot and recognizing the first element as our I value. And in this case, we are going to say, all right, is 3 smaller than 5? And it is. Now, with the algorithm, if the value is smaller than the pivot, that value will swap with the value at position I, and then I will move up. Now, in this process, the value that we're comparing and I happen to be the same. However, the algorithm doesn't know that. So the value is actually going to swap with itself. And then what we are going to do is we will just rewrite these values and we will see the I value move up. Then we will go ahead and we will now compare 5 with 5. And since 5 is not smaller than 5, we'll check it and move on. Now we check 2 with 5, and 2 is smaller than 5. So 2 needs to swap with I. So that will give me 3, 2, 5. We move up our I value, and then we recopy in the rest of the values. And so now we have checked 3 values of our array. Now we move on to the 1, and we check 1, and 1 is also smaller than 5. So we have another swap to perform. 3, 2, 1, 5, move up the I value, 7, 11, 8, 4, and 5 is our pivot. We check the 7, no need to swap, 11, no swap, 8, no swap. We check the 4, 4 is less than 5, so we do have to do a swap. So this goes ahead and swaps with my 5, giving me 3, 2, 1, 4, 7, move up that I, 11, 8, 5, 5, and now we get to the point where we are checking the pivot. When you're checking the pivot, this is when you would swap the pivot with the I value. And as we do this, notice that once I swap the 5 into this position, everything left of the 5 happens to be smaller than it. and everything from this point to the right is either equal to or greater than 5. And that's how I know that I've successfully moved my I value. So we swap the 5 over and we'll have 3, 2, 1, 4, 5, 11, 8, 5, 7. And then this value is now done. And at this point, I'm now going to go ahead and I am sorting these two subarrays. And the value of 5 that is in the middle that I double underlined, this value is done and he is no longer going to move. It's up to you if you want to rewrite it. I find it easier to just leave it the way that it is and not rewrite it because it further emphasizes the values that are already sorted. So let's start with our subarray on the left. So this is my pivot point. This is my I value. And unfortunately, we're going to have a lot of swaps going on here since these values are all smaller than 4. So we check 3. 3 is less than 4, so we need to do a swap. So we move up our I value. We check the 2. 2 is smaller than 4. Need to do a swap. Move up our I value. We check 1. 1 is smaller than 4. Need to do a swap. Move up our I value. Check 4. Oh wait, 4 is in fact the pivot. So now we swap 4 with I, which means we swap 4 with itself. I know sometimes it might seem tedious when we do steps like this where we're rewriting the same array over and over. However, that's how you show me that you understand the process and what's happening within the computer. And if we continue with this process here, this is my pivot, this is my I ask if 3 is less than 1, and it is not. Is 2 less than 1? Nope. So now I get to the end, so I swap the pivot with I. Now the 1 is sorted, and now I'm sorting this guy right here. And from here, here's my pivot, here's my I. Since 2 is smaller than 3, swaps with itself. So I'm going to have 2 and 3. The I moves up. Now I am checking the pivot against the pivot. The value I'm checking is the pivot, so it swaps with itself. So the 3 is sorted. And at this point, I'm just sorting one more value. Once we get to sorting one value, we are in fact at base case. So right now I have 1, 2, 3, 4, and 5 are all fully sorted. And now if we come over here, we can finish off on the right. So when we finish off on the right, we have our pivot value. Here we have our I. And we check, is 11 smaller than 7? Nope. Is 8 smaller than 7? Nope. Is 5 smaller than 7? Yes, it is. So we swap with I, giving me 5, 8, 11, 7. We move up our pivot, and now we're checking the pivot value. Since we've gotten to the end, we swap with the pivot. And remember, when we swap with the pivot, that value that we swap with is done. So here I'm left with a single element and a 2 element. And the single element is done. That's base case. And now over here, I just have a 2 element array. So there's my pivot. Is 11 smaller than 8? Nope. So now I'm on 8. Swap with I. The 8 is done. And I have a single element array, which is now done. So I have my finally sorted array 1, 2, 3, 4, 5, 5, 7, 8, and 11. And there you have it. There is Quicksort. Make sure when you are showing me your work for Quicksort, things that I need to see. I need to see your swaps, and I need to see you label your I value. That is very necessary. That is how you show me that you understand the algorithm.